Hello, and welcome to our Chapter 16 introduction to acids and bases. And in this video, we're just going to take a brief look at kind of our terms, acids and bases, what they're referring to, and indicators that can determine whether solutions we make are acids or bases. Okay, so we're just going to jump right into it. We're going to start by looking at some vocab we'll see a lot throughout this chapter and throughout the rest of the year, really. And to start, we're going to look at pH scale. So the pH scale is just the number line that assigns number of values from 0 to 14. Okay, and this is going to determine, or just not determine, rather indicate whether or not a solution is an acid or a base. So to start, we're just going to keep a kind of simple definition for acids and bases. And so anything that is below 7 on pH scale is going to be a acid. Okay, we'll take a look at some examples of acids a little bit further down. But for right now, anything from between 1 and 6.9 is going to be an acid. Okay, and you can probably guess a base is anything above 7 or between 7.1 and 14. Okay, so we'll talk more. There's a lot of different ways, about 2 or 3 different ways we can define acids and bases besides this very, very brief definition. And we'll talk more about that in the next video, where we look at strong acids and strong bases. So anything below 7 is an acid, anything above 7 is a base, and anything at 7 on the pH scale is neutral. Okay. And so what we have here is we often have these things called indicators, and indicators are basically usually pieces of paper. They change color that help determine the pH of a solution. Okay, so you've probably seen litmus paper. We're going to look at that further down. You might have done that in biology class, where you were measuring the pH, we're measuring if it's an acid or a base, different solutions. And you have a bunch of solutions at home that are acids and bases, and that'll kind of go into another assignment we'll be talking about later on, and you'll be doing throughout the week. So some things about the properties of anything that's an acid or a base. For one, they are often odorless and colorless. So we can't tell by the naked eye or by smelling if something is an acid or a base. It's not that easy, unfortunately. Some other properties, though, they are toxic. Okay, so generally, really strong acids and strong bases are harmful by digesting. Hydrochloric acid, we've seen HCl. That's a strong acid. This is very toxic. And so one more thing that we can use, acids can typically be like sour, might have a sour, like weak acids might have a sour taste to them. Okay. And then bases can often be used as cleaners. A lot of substances that are basic are also cleaners, like soap and like bleach. So if we look below at this model, we can see different substances: lemon juice, drain cleaner, water, vinegar on the top. And we have been using an indicator here to tell us if a substance is acidic, or if it's basic, or if it's neutral. So pink is acidic, so lemon juice, hydrochloric acid, and vinegar are all acids. So you probably have vinegar and lemon juice at your home. Hopefully you don't have hydrochloric acid at your home. And then if we look at the basics, we can see in green here, so ammonium hydroxide, drain cleaner, and that's it. And for the neutrals, we have in purple, salt water, rubbing alcohol, and water. Okay, so we can use indicators again to tell or to change the color of a piece of paper, like litmus paper, to determine if a substance is acidic, basic, or neutral. Okay, so here's our pH scale as a visual model. Like we said, anything between 0 and 6.9, that is acidic. Anything between 7.1 and 14 is basic. And then 7 zone is neutral. Right. Right, so litmus paper, you can get a lot of different colors. So this illustration here, you put litmus paper in a solution that has a pH of about 9, and you'll get a color that looks something like that from the litmus paper. Okay, so we can use that to determine with not quite exact precision, but with a rough estimate of what exactly the pH of the solutions are. And so some acid similarities, anything that all acids have in common, they all will have hydrogens in the beginning or the front of the chemical formula. So for example, we have like HCl, which we've talked about. If we look at vinegar, it also has some hydrogens in the middle here. And lemon juice, which was at the top, C6H8O7. Okay, so they all have hydrogens in the formula. They all have the word acid in the name for when we're talking about chemical substances that we're going to be using in the lab. Okay, so like vinegar is like its product, is its common household name. We can also call vinegar acetic acid, and lemon juice we can call citric acid, and hydrochloric acid already has acid in the name. Okay, and what we also see is that most acids are covalent compounds. Right, so we're dealing with nonmetals, bonding with other nonmetals. And those are the three for acids. For base similarities, we have a hydroxide. The word hydroxide is in the name. So something like sodium hydroxide, which is NaOH, that has a hydroxide in it. And if we look at the formula, and we'll see this for a lot of other, pretty much all basic solutions, they all have that OH, which is called hydroxide in them. All right, so the OH is a good indicator that it's a basic solution, and the hydrogen is a good indicator that it is an acidic solution. And one more thing that is true for all basic compounds is that they are mostly ionic compounds, right, where we have one metal and one nonmetal. It doesn't have to be 1 and 1. Sometimes we see a polyatomic nonmetal bonded with one metal. So we have something like sodium carbonate, like NaCO3, and that is not unusual to see. So those are similarities, 3 of each. You'll need those for the questions below. And just taking a look at these examples, again, we can kind of see where these substances fall on the pH scale. So something like stomach acid that helps you digest food and break down products into smaller molecules that your body can use for energy is all the way at the end of the pH scale, which means it's a really strong acid. Again, we'll talk more about strong acids and bases in the next video. And then stuff like water, rubbing alcohol, salt solution, that's for the most part neutral. And as we get closer to one side, if we go closer to stomach acid, we can see that we are increasing this H+. So those are hydrogen ions, and we're basically increasing the amount or the ability of molecules to donate or get rid of their hydrogen ions. Conversely, if we look at between 7 and 14, as we increase on the pH scale, meaning as we get more basic, we are increasing hydroxide ions, or OH ions, right? So we're increasing the ability of these molecules to donate those OH ions in the solution. Okay, so that was just a rough overview of acids and bases. We'll talk more about them specifically in the next video, and the worksheet is found below. So use the notes that you've been taking to help answer those questions. And as always, if you have any questions, let me know.